Okay, so we're going to keep working with the Pythagorean theorem to find the distance between 2 points on a graph. The way we're going to do that is by recognizing that we could easily make a right triangle between these 2 points. So right here, we can make a right triangle, and we can count how long this side is, 1, 2, 3 units, and how long this side is, 1, 2, 3, 4. And we can realize that these are our two legs. So this is A and this is B. And what we're being asked to find is the distance, which is the hypotenuse, C. So I'm going to do the Pythagorean theorem, A squared plus B squared equals C squared. And we know this is 9 plus 16, which is 25. And then our last step is to take the square root. And so we get that the distance between those 2 points is 5. So let's do the same thing over here. So we'll draw a right triangle connecting the 2 points that we're finding, the distance between. And we'll count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. And we will set up Pythagorean theorem again. These are both of our legs, so that makes them A and B. 8 squared plus 6 squared is 100. And then to find the distance, we take the square root. And so the distance is 10. For this next one, they just give you 2 points. They don't actually give you the line segment, but we can easily draw a line between these 2 points and then make our right triangle. So this to this is our right triangle. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6. Let's work smarter, not harder here. We literally just did a triangle with side lengths of 6 and 8, and we know the distance is 10. This actually introduces us to the idea of a Pythagorean triple, which we're going to look at on the next page. But for now, we'll just say that C is 10. And then we'll take a look at this very last one. Again, drawing the distance or the segment between the 2 points since it wasn't there for us, and going straight down and straight over to make our 2 legs. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And 1, 2, 3, 4, 5. So we're going to set up our Pythagorean theorem. 12 squared plus 5 squared is equal to C squared. 12 squared is 144. 5 squared is 25. That adds to give us 169. And then we finish by taking the square root to get that the distance is 13. So you may notice these numbers come together in triples. So like 3, 4, and 5 at the top, 6, 8, and 10, and just now 5, 12, and 13. These are all called Pythagorean triples because they give us a Pythagorean theorem that works. 3 squared plus 4 squared is equal to 5 squared. 6 squared plus 8 squared is equal to 10 squared. And 5 squared plus 12 squared is equal to 13 squared. So that's what a Pythagorean triple is. So if we flip to page 36, that's exactly what it says here. A set of 3 integers that can be the lengths of the sides of a right triangle is called a Pythagorean triple. The simplest one is 3, 4, 5. And you can use similar triangles and scale factors to get Pythagorean triples. So here, since we know 3, 4, 5 is a Pythagorean triple, what is our scale factor? To get from 3 to 12, we have a scale factor of 4, right? Because 3 times 4 is 12. So we're going to literally multiply all of the sides by 4. 3 times 4 is 12. 4 times 4 is 16. So we can match up those sides. 4 times the scale factor 4 is 16. And 5 times the scale factor of 4 gives me 20. So 12, 16, 20 is also a Pythagorean triple. We use the scale factor to take one Pythagorean triple and transform it to another. So another Pythagorean triple is 9, 12, 15. So let's see, what's our scale factor here? To get from 15 to 30, our scale factor is 2, right? We multiplied everything by 2. So let's do that with the other corresponding sides. So 9 times 2 and 12 times 2 give us side lengths of 18 and 24. So 18, 24, and 30 are also a Pythagorean triple because we just doubled 9, 12, and 15 to find them. So on page 37, let's take the ones that we just had, 3, 4, and 5. We had, this is for a different page, but that's okay. We had 6, 8, and 10. We have 9, 12, 15. We have 30, 40, 50. We have 60, 80, 100. And then we also have 5, 12, 13. These are all Pythagorean triples. So what they want us to do here is take the Pythagorean triples and find some new triples. So for instance, if I took 3, 4, 5 and I scaled it by 2, the new triple would be 6, 8, and 10. And then if I scaled it by 10, the new triple would be 60, 80, 100. If I took the Pythagorean triple 6, 8, 10 and doubled it, I would have 12, 16, 20. And then if I multiplied that by 10, I'd have 120, 160, 200. So fill in the rest of the table using 9, 12, 15, 30, 40, 50, 60, 80, 100, and 5, 12, 13, and fill in the tables with the different scale factors.